Hi, today we're going to talk about the atom and the periodic table. We're going to bypass the bell ringer and now we're going to go straight to the element versus atoms. When I look at the element, basically an element is the simplest thing found on Earth. It's a substance. It can't be broken down into anything simpler. Some examples are any elements you're going to find on the periodic table. Listed below that I have are neon, gold, and also helium, but basically any elements on there. When I look at an atom, basically an atom is technically the same thing as an element, but it is the smallest particle, and I call them like counting units. For instance, if I hold up like 5 black markers, that element would be the black marker, but your atoms would be how many I had on hand, and it would be 5 of those. So atoms are your counting unit, is how many of that particular element. Now when we look at the history of the atomic model, we're going to start first of all with Democritus. So Democritus basically was the first guy. He was a Greek scientist, and he viewed atoms as being the smallest particle out there. He actually coined the phrase atomos. Then basically atoms were studied almost non-existent until about in the 17th century, where John Dalton actually came up with the theory of how atoms are classified. He came up with 4 points, but we're not going to worry about that at this point. If you take chemistry, we'll go more in depth. Then there's J.J. Thomas, and J.J. Thomas coined the actual particle electrons, and he did this by one morning looking at his food and saw that it was the plum, looking at the plums in his pudding, and called his ideas the plum pudding theory, whereas the plums represented the electrons that are located in an atom. Later we had Ernest Rutherford, and basically he's the one that noted that the mass, predominantly most of the mass, was located in the nucleus. He actually did this through a gold foil experiment where he bombarded small particles found in the nucleus like protons, and actually found that they actually penetrated some of the gold foil. On the next slide we're going to study for this unit is Niels Bohr. Niels Bohr basically came up with how electrons are found. He established those energy levels or orbitals or shells. It could be all 3 names, and noted that those electrons are found there. And then the last one is the current model that we use today. It's the electron cloud model, and this is where the electrons are moving so fast that they create this dust or this cloud appearance. We have 3 subatomic particles, and the first 2 I'm going to talk about are predominantly found in the nucleus. We have protons, and protons are positively charged. They have a mass of 1. So try to remember P for proton, P for positively charged. We have neutrons, which are neutral. They basically have no charge. So when you look at the word neutrons, take off ON and add an AL, you've got its charge. And then you have electrons, which are negatively charged. They're located on the outside of the atoms. Okay, they have a tremendous, extremely small mass, so we don't hardly notice their mass at all. Okay, our next slide, we're looking predominantly at the nucleus. And so what we have in the nucleus, again, that's where the protons and neutrons are located. When you see the diagram to the right, in the black circle is the nucleus, and that's where you see the neutrons and protons. Because the neutrons have no charge, they're taking the charge of the protons. Then you have the energy level, shells or orbitals, and this is where those electrons exist. So therefore, the charges there would actually be negative. Here we have a picture of a snapshot of oxygen, the block of information from the periodic table. When you look to the top of the number, or the top number up there, that is the atomic number, and that identifies the actual element. I like to call it its DNA. If you change its number, you're talking about a totally different element. So therefore, it identifies the number of protons. Now there is a little secret there. If it's not blending or mixing with anything else, it also identifies how many electrons are found in there. Our mass number, again, is the largest number. It's the mass, where a majority of the stuff is located. And remember, in the nucleus, we said that that's where our protons and neutrons are located. So we're going to add them together, and what you get at the bottom is the average atomic mass. It is, again, the number at the bottom, and typically what we want to do is actually round it up to the nearest whole number. Okay, and the next one is, just to recap again, here we have a snapshot of neon. The top number up at the top is the atomic number, which again identifies the number of protons. We have the symbol for neon. It's capital N. The second letter is always lowercase. Then we have the name, and then we have the mass number. Now note it's not rounded at this point. It's the average. Okay, so how do I find each of these? Just to recap again, to find your protons, it's the number up top called the atomic number. To find your electrons, again, if you know protons, you know electrons. They're the number of protons. And then to find your neutrons, basically you're going to take your mass number and subtract it from the atomic number. Okay, another way to view that is big number minus small number. Okay. And here we're going to let you practice with neon, boron, and I want you to write its symbol, atomic number, mass number, the number of protons, number of electrons, and then how many neutrons are found in there. Remember, you're going to have to calculate the number of neutrons. Thank you.